An overhead projector is a variant of slide projector that is used to display images to an audience. Optical system. An overhead projector works on the same principle as a 35 mm slide projector, in which a focusing lens projects light from an illuminated slide onto a projection screen where a real image is formed. However, some differences are necessitated by the much larger size of the transparencies used, and the requirement that the transparency be placed face up. For the latter purpose, the projector includes a mirror just before or after the focusing lens to fold the optical system toward the horizontal. That mirror also accomplishes a reversal of the image in order that the image projected onto the screen corresponds to that of the slide as seen by the presenter looking down at it, rather than a mirror image thereof. Therefore, the transparency is placed face up. In contrast with a 35 mm slide projector or film projector where the slide's image is non-reversed on the side opposite the focusing lens. Condenser. Because the focusing lens is much smaller than the transparency, a crucial role is played by the optical condenser which illuminates the transparency. Since this requires a large optical lens but may be of poor optical quality, a Fresnel lens is employed. The Fresnel lens is located at the glass plate on which the transparency is placed, and serves to redirect most of the light hitting it into a converging cone toward the focusing lens. Without such a condenser at that point, most of the light would miss the focusing lens. Additionally, mirrors or other condensing elements below the Fresnel lens serve to increase the portion of the light bulb's output which reaches the Fresnel lens. In the first place, in order to provide sufficient light on the screen, a high-intensity bulb is used which must be fan-cooled. Focus adjustment. Overhead projectors normally include a manual focusing mechanism which raises and lowers the position of the focusing lens in order to adjust the object's distance to focus at the chosen image distance given the fixed focal length of the focusing lens. This permits a range of projection distances. Increasing the projection distance increases the focusing system's magnification in order to fit the projection screen in use. Increasing the projection distance also means that the same amount of light is spread over a larger screen, resulting in a dimmer image. With a change in the projection distance, the focusing must be readjusted for a sharp image. However, the condensing optics is optimized for one particular vertical position of the lens, corresponding to one projection distance. Therefore, when it is focused for a greatly different projection distance, part of the light cone projected by the Fresnel lens towards the focusing lens misses that lens. This has the greatest effect towards the outer edges of the projected image, so that one typically sees either blue or brown fringing at the edge of the screen where the focus is towards an extreme. Using the projector near its recommended projection distance allows a focusing position where this is avoided and the intensity across the screen is approximately uniform. Source of illumination. The lamp technology of an overhead projector is typically very simple compared to a modern LCD or DLP video projector. Most overheads use an extremely high-power halogen lamp that may consume up to 750 watts. A high-flow blower is required to keep the bulb from melting due to the heat generated, and this blower is often on a timer that keeps it running for a period after the light is extinguished. Further, the intense heat accelerates failure of the high-intensity lamp, often burning out in less than 100 hours, requiring replacement. In contrast, a modern LCD or DLP projector uses an arc lamp which has a high luminous efficacy and lasts for thousands of hours. A drawback of that technology is the warm-up time required for arc lamps. Older overhead projectors used a tubular quartz bulb which was mounted above a bowl-shaped polished reflector. However, because the lamp was suspended above and outside the reflector, a large amount of light was cast to the sides inside the projector body that was wasted, thus requiring a higher power lamp for sufficient screen illumination. More modern overhead projectors use an integrated lamp in conical reflector assembly, allowing the lamp to be located deep within the reflector and sending a greater portion of its light towards the Fresnel lens. This permits using the lower power lamp for the same screen illumination. A useful innovation for overhead projectors with integrated lamps, reflectors is the quick-swap dual lamp control, allowing two lamps to be installed in the projector in movable sockets. If one lamp fails during a presentation, the presenter can merely move a lever to slide the spare into position and continue with the presentation, without needing to open the projection unit or waiting for the failed bulb to cool before replacing it. History. Also called the view graph, the overhead projector was created by Jules Dubosc, a French inventor, in the 1870s. It was first used for police work, and used a cellophane roll over a 9-inch stage, allowing facial characteristics to be rolled across the stage. The U.S. Army in 1945 was the first to use it in quantity for training as World War II wound down. It began to be widely used in schools and businesses in the late 1950s and early 1960s. A major manufacturer of overhead projectors in this early period was the company 3M, where engineer Roger Appledorn had developed a transparency projection system. As the demand for projectors grew, Boole Industries was founded in 1953, and became the leading U.S. contributor for several optical refinements for the overhead projector and its projection lens. In 1957, the United States' first federal aid to education program stimulated overhead sales, which remained high up to the late 1990s and into the 21st century. Use in education. The overhead projector facilitates an easy, low-cost interactive environment for educators. Teaching materials can be pre-printed on plastic sheets, upon which the educator can directly write using a non-permanent, washable color marking pen. This saves time, since the transparency can be pre-printed and used repetitively, rather than having materials written manually before each class. The overhead is typically placed at a comfortable writing height for the educator and allows the educator to face the class, facilitating better communication between the students and teacher. The enlarging features of the projector allow the educator to write in a comfortable small script in a natural writing position rather than writing in an overly large script on a blackboard and having to constantly hold his arm out in midair to write on the blackboard. When the transparency sheet is full of written or drawn material, it can simply be replaced with a new, fresh sheet with more pre-printed material, again saving class time versus a blackboard that would need to be erased and teaching materials rewritten by the educator. Following the class period, the transparencies are easily restored to their original unused state by washing off with soap and water. LCD overhead displays. In the early 1980s-1990s, overhead projectors were used as part of a classroom computer display projection system. A liquid crystal panel mounted in a plastic frame was placed on top of the overhead projector and connected to the video output of the computer, often splitting off the normal monitor output. A cooling fan in the frame of the LCD panel would blow cooling air across the LCD to prevent overheating that would fog the image. The first of these LCD panels were monochrome only, and could display NTSC video outputs such as from an Apple II computer or VCR. In the late 1980s, color models became available, capable of thousands of colors, for the Color Macintosh and VGA PCs. The displays were never particularly fast to refresh or update, resulting in the smearing of fast-moving images. But it was acceptable when nothing else was available. The do-it-yourself community has started using this idea to make low-cost home theater projectors. By removing the casing and backlight assembly of a common LCD monitor, one can use the exposed LCD screen in conjunction with the overhead projector to project the contents of the LCD screen to the wall at a much lower cost than with standard LCD projectors. Due to the mirroring of the image in the head of the overhead projector, the image on the wall is reflipped to where it would be if one was looking at the LCD screen normally. Decline in use. Overhead projectors were once a common fixture in most classrooms and business conference rooms, but today are slowly being replaced by document cameras, dedicated computer projection systems and interactive whiteboards. Such systems allow the presenter to project video directly from a computer file, typically produced using software such as Microsoft PowerPoint and LibreOffice. Such presentations can also include animations, interactive components, or even video clips, with ease of paging between slides. The relatively expensive printing or photocopying of color transparencies is eliminated. The primary reason for this gradual replacement is the deeply ingrained use of computing technology in modern society and the inability of overheads to easily support the features that modern users demand. While an overhead can display static images fairly well, it performs poorly at displaying moving images. The LCD video display panels that were once used as an add-on to an overhead projector have become obsolete. With that combination of display technology and projection optics now optimally integrated into a modern video projector, the standards of users have also increased, so that a dim, fuzzy overhead projection that is too bright in the center and too dim around the edges is no longer acceptable. The optical focus, linearity, brightness and clarity of an overhead generally cannot match that of a video projector. Video projectors use extremely small picture generation mechanisms, allowing for precision optics that far exceed the plastic Fresnel lens optical performance. They also include additional optics that eliminate the hotspot in the center of the screen directly above the light source, so that the brightness is uniform everywhere on the projection screen. Critics feel that there are some downsides, as these technologies are more prone to failure and have a much steeper learning curve for the user than a standard overhead projector. Also, the overhead projector allows a more direct interaction through live writing on the transparency.